Hello, everyone. Welcome to our our webinar regarding our second exchange scheme open call for the ENFIELD project. Just wanted to remind you that the whole session will be recorded and it will be available for you to check anything in our web page. So the agenda for today, first we will start with an introduction of our project, ENFIELD project. Then we will present you the 21 scientific challenge for this second exchange scheme open call. Thirdly, we will navigate the open call. You will learn everything regarding how to apply, how is the eligibility criteria and the evaluation process from the beginning until the end. And then we'll have an open session for questions and answers. Just regard the questions itself, if you want to make them, please use the Q&A tab that we have available in this webinar. And we will be replying also during the whole time to these questions. If you have a specific question regarding one specific challenge, please, before asking the question, make sure that you identify that challenge. For example, if it's for Green AI, challenge 3, write Green AI / Green AI dot 3. So starting first with presenting you our project. So ENFIELD stands for European Lighthouse to Manifest Trustworthy and Green AI. And as this name indicates, the goal of this project is to generate and share knowledge in AI and AI research. So the overall goal is to contribute to the creation and establishment of the European AI Lighthouse. This is a project of 3 years. It started last year in September 2023 and will last until August 2026. Since the goal of the AI Lighthouse is to mobilize the AI community to collaborate on key areas and challenges in this research. This project have envisioned 6 different open calls to mobilize this community. We'll have 4 open calls to select researchers to do fundamental research in AI topics connected to pillars and verticals of the project that we will explain a bit later. And we will have also 2 open calls to select at least 18 projects from R&D institutions to conduct applied research in key areas of the project. The overall goal then is to promote and generate the generation of research and innovation across different stakeholders in Europe. So as I was saying, our project ENFIELD is divided in 4 pillars and 4 verticals. So for pillars, we have green AI, adaptive AI, human-centric AI, and trustworthy AI. And the goal of these 4 pillars is to promote research on the fundamental aspects of AI across these areas. Corresponding to these 4 pillars, we have 4 verticals also in the project, which refer to the industry sector and the uptake of these pillars for specific areas, namely energy, healthcare, manufacturing, and space. So the overall goal here of the project with these 4 verticals and 4 pillars is to promote research or applied research across these areas to generate knowledge on AI for both the European industry and the academic partners. Our consortium has 30 different partners from 18 countries. You can see all of the logos of the partners here. Most of them, so 2/3 of them, so around 20, are from academia and research centers, and we have 10 partners from an industry and small and medium enterprises. As I was saying in the beginning, and we are here today to with a dedicated webinar for the open calls. But this project envisioned two types of open calls. The ones that we are interested in discuss today is the exchange scheme dedicated to applied research, and where we will grant directly the researchers to move to one of our partner institutions. And then we have as well the innovation scheme that will not be talking today, but we'll have another call next year. So just focusing on what is important here, which are the exchange scheme open call. This is the second one that we are launching. The first one was in March this year. The overall goal that we have in the project is to fund at least 76 researchers throughout the 4 open calls that we have, and we have a budget of 1.1 million euros to do it so. We are now in the second open call that is currently accepting applications, and will be running until mid-October. And for this second exchange scheme open call, regarding the pillars and verticals that we explain that our project is divided in, we have challenge for each one of the categories. So we have in the pillars for adaptive AI 5 challenges proposed, 3 for green AI, 4 for human-centric AI, and 5 for trustworthy AI. In terms of verticals, we have 1 challenge proposed for both healthcare and energy, 2 for manufacturing, and in this open call, we don't have any challenge proposed for the space vertical. So what we will do next is the presentation by each one of the partners regarding the challenge. Again, if you are to question anything regarding this challenge, please identify the question first before putting the question, identify first the challenge for us to be able to address your questions. So starting with the first challenge, I would like to give the floor to Eric. Eric, please go ahead.
Yes, hello, can you hear me?
Yes.
Good. So the first challenge of the green AI pillar is about green generative language models. And generative AI, and especially these large language models, are one of the core reasons why we have to work with green AI, trying to make AI a little bit more sustainable and less energy demanding. So the scientific challenges we are working with in this challenge is there are 3 different aspects, really. One is to be able to obtain reliable measurements of the energy usage across different hardware setups and different deployment scenarios. Then it is also about being able to assess the balance of the high energy costs or resource costs in general and the actual value that we get out of the practical applications of these language models. And the third thing is to try to optimize the energy efficiency of the large language models without sacrificing performance, having adequate performance but trying to make it less energy intensive. So these are very, let's say, open and flexible aspects that could, there are many different ways of working towards these challenges, but some of the research activities that we envision as a part of this challenge is to, for example, analyze energy consumption patterns to identify inefficiencies in different types of models, types of architectures, and also across different deployment scenarios, trying to explore different techniques to save energy, and also investigate trade-offs between how to use the language models, for example, for fine-tuning or in-context learning. So overall, what we want to achieve is to get some energy-efficient methodologies to analyze and optimize large language models, some new techniques to make the energy consumption of these models smaller, and also look into refined criteria for selecting the most energy efficient models. But overall, this challenge is very open to many different proposals and methods for making language models a little bit greener. Thank you.
Thank you, Eric. Next, we will have Bernard to present Green AI Challenge 2.
Hello, can you hear me?
Yes, we can hear you.
Excellent, thank you very much. So the Green AI .2 challenge is situated in the research focus on Green AI on the Edge Cloud Continuum. And we are here mainly concerned with reducing the energy consumption of machine learning models on the one hand side, and also reducing the energy consumption of first principle simulations. So we're now talking about fields in which we can create hybrid models in which mathematical theories, physical theories, social theories are available to bring these theories inside the machine learning model in order to reduce reduce the energy consumption of them, but also use machine learning models to replace computationally costly numerical simulations. And scientific challenges, first of all, include these reduction techniques, but also quantifying the resulting energy savings by doing that and characterizing the trade-offs between the energy that is required for creating training data, energy of the model and its runtime, and the accuracy of the resulting model. We also envision a certain set of research activities. This could be hybrid modeling, where you couple a finite element method simulation with some data-driven submodel, or where you use an agent-based model and couple it with a machine learning model, so that the overall system has the same accuracy for a lower number of computations. We also consider including knowledge-based systems, like knowledge graphs or approaches like that. Finally, we will look at ways how to include prior knowledge into machine learning models. Maybe physics-informed neural networks, or PINs, are a term that is known to some of you. And finally, also causal machine learning or causal data science can be employed to reduce the energy consumption by bringing in prior knowledge. The expected results would be energy-efficient hybrid models or surrogate models, with the main aim to reduce the energy consumption and runtime of first principle simulations, and incorporating prior knowledge into existing AI systems. If you have any questions, I'll stick around for them later. Thank you very much.
Thank you, Bernard. Next, we will have Alfredo presenting the Green AI Challenge number 3.
Hello, can you hear me?
Yes, we can hear you. Go ahead, Alfredo.
Okay, thank you, Marina. Okay, my name is Alfredo. I'm a professor and researcher at UCM in Madrid, and as my colleagues, I'm going to present the challenges, research activities, and potential results in the metrics branch of the Green AI pillar. Considering the challenges, we're missing a standard way to measure green AI across different systems. Things like algorithm efficiency, accuracy, and the environmental impact throughout the entire AI life cycle aren't being tracked consistently. And well, to fix this, we really need people from different fields working together, making sure any metrics we come up with are both technically solid and truly reflect environmental concerns. Another challenge could be that we really don't have enough of the full data needed to really understand the environmental footprint of AI technologies yet. So the research activities proposed could be summarize the state of the art about existing frameworks and tools to estimate the carbon emissions, develop real-time tools and libraries that provide live metrics on emissions and energy usage while models are being trained or utilized, and basically apply these solutions into real-world industrial scenarios like, robotics, economics, healthcare, where probably time series and deep learning models are key players. Finally, the expected results of this research could be compare the tools developed during the project with what's already out there, benchmarking them with to see how they perform, basically. Build new real-time tools in various programming languages, could be C, C++, but also Python or more advanced like R. Introduce fresh metrics and guidelines to help creating greener algorithms, develop new algorithms that include these metrics or other existing ones as part of their own design, or test all this in real world industrial scenarios to make sure that they're practical and impactful. These are just some keys, but obviously we're open to different research ideas on green AI metrics. And that's all. Thank you, Morena.
Thank you, Alfredo, for your presentation. Next, we will have Van Tam presenting the next two challenges in adaptive AI. Van Tam?
Okay, sorry, I was.
We can hear you now. Yes.
Yes. Hello, everyone. So, yes, I'm very happy to present you the two challenges on adaptive AI. The first one is adaptive AI on the edge. As you may know, AI on the edge, one of the main challenges is the limited resources, especially limited memory capacity, limited computing resources, and also limited energy efficiency, or high efficiency required. Another challenge for AI on the edge is that we have it depends on applications. So the data set we have there is kind of new, and so we cannot use kind of existing model, AI model available for different applications we know. So we have to decide first AI model suitable for our specific data set. And it could be very difficult task if it is not automatic. So one solution to use NASH, it's neural architecture search. But the neural architecture search could require a very big computing resources for to run that kind of algorithms. So what we propose in this challenge is to use kind of different sort of NASH approaches. We take into account different hardware architectures and target in terms of latency, in terms of energy and memory, and then how and design AI model from the NASH approach in a more optimal and automatic ways. So in terms of research activities, so first of all, we have to address the challenges by exploring existing solutions. And also we propose hardware-aware NASH, so which is different sort of NASH approach framework, which will automatically research for efficient AI model on different hardware types and target. All that should be done taking into account constraints related to computing energy and memory capabilities. And also in order to have more efficient search algorithms, we need to approximate the cost function to optimize, taking into account the hardware performance on a given platform. So we have quite a big team working on that topic, almost 20 students, including master and PhD students. So if any candidate jump on that topic, we can have some interesting result quite fast. So the main expected result is on publications with the existing result we have currently. And also we would like to have more close collaboration with vertical pillar, especially on healthcare pillar. Next slide, please. A second challenge is on resource content training because so now when we talk about AI, mainly is on neural networks architecture base, and as you may know, the architectures can be very huge, especially those based on transformer, for example, and to train that kind of model, the main algorithms based on backpropagations. And for the backpropagation, it's not very efficient algorithms for training, even on cloud GPU or on cloud storage GPU, and especially in constrained resource constrained systems, for example, on the edge, it's almost not possible. So currently in our projects, we try to propose training mechanism, training algorithms, which will limit, or remove backpropagation, so more efficient way. And also another interesting thing is that what happened in our brain. So in our brain, we learn a lot of different things in more efficient way, and we don't use backpropagation mechanism. In terms of research activity there, the first activities will be define task adaptive spark update. So we don't need to update every parameters in the model. Maybe we can identify some relevant parameters to update and in a very dynamic way in order to reduce the resources. And the second is to use the gradient approximator. So we not use a very classical gradient descent, but we define an approximation of the gradient, and then to implement another mechanism. So which will not gradient descent, but it's close to, which will be more efficient in terms of memory usage and compute capabilities. And also another iteration could be to use low-rank propagations, which is quite new. The idea is, so we have feed forward, we have backward, and in the backward as well as feed forward, we will use low-rank approximation in order to optimize and to reduce memory usage and also computing resources for backward and also for forward. In terms of expected result, it will be the same. We have worked on that project for a while. And then even for 6 months or so, candidate can work with PhD student and postdoc working on that topic for a while. And then we expect mainly in terms of publications, and also we would like to have collaboration with other industrial partners in vertical, especially in healthcare sector. Is that all from my side? Thank you.
Thank you, Van Tam, for the presentation of these two challenges. The next presenter could not be present today, but he will send us a recorded, so we'll show you the next challenge. We cannot hear it.
Yeah, I don't know if other guys here, but we don't hear him. We don't hear the video.
Yes. Okay. So I don't know the problem at the moment because the PowerPoint is working. I can hear, but maybe because we are in the meeting, I don't know how we can solve this.
I believe it's from your voice settings. You can include the voice that's coming from within your laptop. So just look at the microphone configuration in the Teams.
Okay, I will try really quickly if I can do that. If not, we will then share the audio with everyone. Okay, let's try again to see if, please let me know if you can hear or not. No, so we cannot, unfortunately, this is an unforeseen problem at this, I'm sorry for that. We thought that this could work, and in fact is working, but during the presentation, in presentation mode here on Teams, I cannot do it, and to not delay the presentation of the webinar, what we will do is go through this slide of the adaptive AI, and we will send everyone that was here present in the webinar the recorded regarding this specific challenge. And if any questions arise, we will also add the contact of our team, and you will be able to contact us directly to have any question clarified with this slide. I'm sorry for that, but let's move to the next challenge then. And for the next challenge on adaptive AI, challenge 4, we'll have Shruti presenting. So please go ahead.
Yes, thank you. Hello, everyone. So I am Shruti Gowda from Eindhoven University of Technology in Netherlands. So we have two challenges in our lab. We work a lot on like neuro-inspired AI, like brain-inspired, which basically is like identifying the challenges and gaps between the workings of a brain and then the networks, and then try to like, bridge that gap in different ways. And we work on different domains, continual learning mainly, and also in adversarial robustness, multimodality. So for the first challenge, we want to develop like the most effective and efficient continual learner. So continual learning is when like data is sequential, keep streaming, and we keep learning new data without forgetting the old data. So that is one of the big problems in continual learning, forgetting. So we want to develop like newer algorithms, newer architectures, newer learning mechanisms to improve continual learning. And for this, we also want to see if we can leverage like multimodality, either VLMs or LLMs, to see how these modalities can like combine to reduce forgetting during lifelong learning. And also here we want to explore efficiency. So it's like a two-part. So there is freedom to like explore on different things here. Like we want to bring up more efficient algorithms, introduce sparsity, like with different mechanisms, and like try to develop more efficient and effective continual learning methods. And our results, like it is similar to the others, like we would expect a publication, and as well as it is good to have a collaboration. It's not like strict mandatory. We want to encourage it, of course, with any different vertical in an application domain. But main would be to like develop like efficient continual learning algorithms, and then add sparsity to make it more efficient to learn, run on like embedded resource constrained devices. And I think the next slide is also from us. Here we are dealing with generalization and robustness. Again, like for example, humans, when we add like some noise or like attacks onto the image, we can still distinguish it, but networks like do misclassifications when we add any kinds of like well-crafted noise into the images. So all the networks are quite vulnerable to these kind of alterations. So this is a challenge, and we want to like work towards enhancing robustness and generalization, not just like, because one of the pitfalls is also like when we try to improve robustness, we reduce the accuracy on standard, which is not good. So we want to get a well balanced result. So here the activities, like now VLMs and LLMs are taking off. We also want to see like in these models, languages or vision and language together, how are they robust? Are they robust enough for these kind of attacks? What are the different kinds of attacks for these specific new models, and how can we evaluate it? And after this, like evaluation, we also want to like devise a new methodology, different evaluation, different benchmark to like help improve the robustness of these networks. Again, the results remain the same, like the expectation is a publication and if possible, collaboration with any of the application domain verticals. And there is a lot of freedom to explore. So anything you're interested in, we can like have a look and discuss more for sure. Thank you.
Thank you so much. The next slide regarding human-centric AI, the first challenge in this pillar will be presented by Francisco.
Thank you. So I think my microphone is all right. You can hear me?
Yes, we can.
Great. So this topic is called Involving Small Models for Decision Making. And the main scientific challenge behind this is to grow symbolic models from data based on interactions between an AI decision system and the environment. The idea of symbolic here is to have a model that is inherently interpretable for the user. And we also, given that, we also want to introduce the human in the learning loop. In this case, it can be by defining the first version of a symbolic model. It can be by proposing different mutations to this model through its learning process. This is part of the scientific challenges. The research activities that are in this topic are three, mainly three. One of them is to study different symbolic representations. This can be for decision problems or for control. Things like automata theory may need to be studied more, okay, or be a source of inspiration. Then we also have the development of symbolic search methods based on well-established search-based algorithms. Right now, this topic has been advanced a little bit, and we have been using simulated annealing in this case, but we want to expand this to the use of Monte Carlo tree search, and we also want the search-based algorithms to be able to do mutations in a different way. Since these are symbolic models, we are also trying to include the use of large language models in the place of the system that does the mutations, let's say, of these models. And we want application of the developed approach in verticals, namely in energy, of course. Expected results of the development of this new method that touches the research activities that I mentioned, that is capable of learning from data within a reinforcement learning framework. And of course, we expect that the code that corresponds to this method is published in open source, so in GitHub in this case, and one peer-reviewed publication, preferably in a top-tier journal or conference, as said there. And that's it. The hosting institution is in Azure.
Thank you so much, Francisco, for the presentation. The next challenge will be presented by Jarek, the Human-Centric AI Challenge 2.
Yes, great. So my name is Jarek. I am a research scientist at Telenor in Norway. We have an office quite close to Oslo, and the challenge I'm presenting is on user perspectives on explainable AI within the human-centric AI pillar. So the challenge we are dealing with is that to make our employees and basically any users trust AI systems, it requires a high threshold. And one of the ways people have tried to address this is through a variety of explainability features. Lots of technical work on feature importance and confidence scores, etc. But the field experiments with these technical features tend to yield mixed results on their effectiveness when it comes to increasing the trustworthiness of AI solutions. So the challenge we pose is to investigate user preferences for AI explainability through a variety of methods, through interviews, survey experiments, mock-ups, and more realistic scenarios, basically to explore a balance between transparency, complexity, and effectiveness of various explainability solutions. And yeah, the goal is to get some quantitative measurements and figure out what works, what does not work, and to go beyond just finding solutions that are tested like on a random population through an online platform, but sort of a more realistic scenario with people employed in a corporate environment and even technical workers. So yeah, as research activities, we envisage mapping user attitudes and perceptions through interviews and surveys and testing, actually, perhaps through some mock-up of the solution and A/B testing, a variety of explainability features. And the goal is to get concrete recommendations on AI system design and identify factors that have an impact on user trust and usability of these AI solutions. And we expect that the findings will be reported in a peer-reviewed publication. Thank you.
Thank you, Jarek. So the next challenge in human-centric AI, the number 3, will be presented by Mohammed.
Oh, thank you, Mariana. So, yeah, my name is Mohammed. I am from Budapest University as a researcher in Hungary. So today I am going to present our first challenge as child-centric AI for personalized and safe educational voice assistants. Actually, I will start with the goal. So our goal here is to develop AI model that adapts to individual children learning needs. This involves actually creating systems that understand different learning styles and modify their response accordingly. So for scientific challenge, so our first aspect is ensuring the safety of children using these tools. So we are implementing monitoring features and parent control, making sure children are protected while using these assistants. So this is our first challenge. The second challenge, we need to have some privacy and also ethics are also important. So we need to handle the child-specific voice data carefully and securely. So in terms of research, I think it's better to work on improving personalized learning experience and also testing the safety mechanism. But before that, we need to design our AI model and then addressing at the end the privacy and concerns. The outcomes that we need from the researchers include a better AI models and also a deeper understanding of privacy for kids, these technologies. We need for, let's say, 1 peer-reviewed publications on advancement in educational voice assistance and safety measures. So I hope these kind of things is helpful for you. Thank you.
Thank you. Next, we will have Adina presenting human-centric AI challenge number 4.
Hello, everybody. My name is Adina Flora. I'm professor at University Polytechnic of Bucharest. And the topic novel explainable AI methods for decision making is, of course, subsumed by the general goal to develop new or improved ways to ensure a human-centric AI decision process. Now, the focus of this topic is to try to improve or give new explainable methods for deep neural networks models that are based on spatial temporal data. For example, multimodal or spatial temporal transformers. We know that these kind of structures have to deal with complex time varying information, and therefore understanding the process, evaluating if the results and outcome are okay is very difficult, and therefore explainability is critical. Of course, we have to start from understanding user requirements for explainability and interpretability of these models. And in this domain, we can make a connection with the user perspective that was already presented in human-centric AI 2, We have to develop new explainability methods for these structures. We focus, as I said, on spatial temporal transformers, but we had previous experience to model spatial temporal data using graph neural networks for human activity recognition. And we would like, in order to enhance the interpretability of this model, to connect the explanation with some kind of high-level representation of the process. As research activities, the holder or the holders of this topic would have to design and implement explainable algorithm for these kind of models, to propose AI methods to capture the flow of information and dynamics in such spatial temporal structure, to explore the different approaches to link to a symbolic representation, but also to evaluate from a qualitative and quantitative point of view the quality of explanation, which is very important. Expected results are high-level explainability method, one method, and one or several algorithms for decision-making. Application and validation for a use case. This use case can be from healthcare, for example, combine data from medical images with patient data, or analyze temporal changes in images in order to track progression of disease and predict evolution, or in human activity recognition, which can be used in a context of ambient assisted living or manufacturing. We expect at least one peer review publication, preferably in a top-tier journal or conference. And as you can see, there are three partners in the consortium, UPB, TU, and INESTEC, who would like to receive such an exchange scheme. Thank you for your attention.
Thank you, Adina, for the presentation of the challenge. And next we move to the last pillar, trustworthy AI, and we will have again Mohammed presenting this first challenge.
Hi again. So thank you very much again for Mariana. So today now I would like to present our second challenge in regard to the trustworthy. So is it secure voice biometric with fake voice detections? So here we aim to create again AI models that can tell the difference between the real and the synthesis voice. So here our major challenge is dealing with different kind of accents, background noise, variation also in voice quality. So the focus in this topic, creating system that can detect fake voice. So that kind of technology is important in more areas like finance, healthcare, and also secure access control. So to do so, the researcher need to do some researching new anti-spoofing techniques, such as trying with the signal processing, machine learning, prevent, and manipulations of voice data. So the result that we expect from the researcher to enhance these voice authentications technologies and develop robust algorithms that can protect against voice spoofing. By the end also of this topic, we expect again from that researchers to have more improvement, not only in the AI models, but also the security and trustworthiness of voice biometric. And of course, publishing one peer review is much important to publish these findings. Thank you very much.
Thank you, Mohammed, for your presentation. Next, we will have Carla from INESTEC presenting the second challenge on the trustworthy AI.
Hi, can you hear me?
Yes, we can.
Great, thanks. So my name is Carla. I am a researcher at the Center for Power and Energy Systems at INESTEC, located in Porto, Portugal. Our topic here is privacy-preserving nonlinear models for time series, for multivariate time series. We propose this topic because there is a huge potential to improve time series forecasting models if we consider data from multiple geographical locations. However, different companies usually collect this data and are unwilling to share it. And that being said, the main challenges are how can data privacy be ensured in cases where different data owners observe different time series? And at the same time, how can we construct an interpretable model? In terms of research activity, we would like to explore CANs because CANs are neural networks. They are interpretable. And we would also like to investigate vertical federated learning with fusion models. So fusion models are traditionally used to merge data from different types. For example, a neural network that receives video and text as input. There are many architectures for these fusion architectures, from early fusion to late fusion, where in this late fusion there are no mixed connections between the different types of data until the last node of the neural network. So it's like we construct two different neural networks that just mix in the final point. So ideally, we would like to integrate these CANs with this idea of fusion models to ensure data privacy without the need to use heavy encryption protocols. But of course, we can also explore simple encryption protocols as well if there are candidates that would like to also explore encryption techniques. Finally, as expected results, we would like to advance a privacy-preserving vertical federated learning approach. Ideally, we would like to apply it to the energy vertical, so with data from renewable energy, production or load consumption or power consumption. We would like to have a scientific publication and maybe a collaboration extending behind the research visit. So that's all. Thank you.
Thank you so much, Carla. To present the next three challenges that complete the challenge group for this open call for trustworthy AI, we will have Abu Bakr.
Yeah. Hi. Thank you, Mariana.
Hi,
This is Wakar Gaber from TUC. So basically, the first challenge I will be talking about security and robustness of AI systems. So in general, machine learning's getting targeted and attacked by cybersecurity attacks. What our challenge currently is detecting these attacks and defending against them is currently challenging. And not only machine learning, but LLMs as well, having like prompt attacks against them. And defending these attacks and detecting them is currently challenging. And the second challenge, we have also AI security by design approaches currently not well implemented, and which can help us preventing the whole thing from the beginning during the development. And of course, monitoring and measuring AI security systems is also considered a big challenge for the current time. So research activity, these three challenges as well, the next two, is actually wide open topics. You can propose your own ideas and maybe identifying an interesting topic in this related that can be contributed to this related area in the research. And of course, the second research activity, you need to conduct a literature survey on that, and finally propose a novel approach for that topic and develop a proof of concept. Expected results, of course, at least one peer-reviewed paper, and of course, novel scientific results for increasing the trustworthiness of AI, and finally, overall will be contributing to the trustworthy AI framework for EU. The second one is actually, second challenge is relatively close to the first one, which is privacy and compliance of AI system. So as we mentioned before, currently there is an attacks on AI, and also there is some issues by can cause a privacy leakage in the AI system. Identifying that leakage is currently challenging, and creating methodologies to enhance the AI overall AI system privacy is currently limited somehow. And of course, utilizing cryptographic techniques to enhance the privacy overall of the AI also not well documented and not well integrated. So basically similar to the previous one, trying to identify some interested topic in this area and conduct a literature survey and propose a novel approach for it, and finally develop a proof of concept. The output, expected result, we are expecting at least one peer-reviewed and of course a novel scientific results to increase the trustworthiness of the AI system overall, and finally again contribute toward the trustworthy AI framework for EU. The final one is AI in distributed system. So basically distributed system generally is complex by itself. Adding an AI component to that make it more complex. And mainly one of the main challenges currently we are facing in that is actually addressing the trust in the modeling itself for the distributed systems. So basically what we have currently is there is no measurement for the trust aspect in general, not only for AI. And currently the other challenge also, there is some communications happening between, if you have multiple AI components in the same system, there is some communication happening between the AI system and the regular system of yours. And of course, within these AI systems or component itself, there is some communication happening. Monitoring this communication and observe them is currently challenging. And the other aspect, we currently don't have any visual tool to represent the AI component and its aspect in within the architecture of the system. So our research activity for the current moment, we are working in taxonomy of trust and distributed systems, and we need to extend that. And the other thing is actually we don't have a suitable visual modeling system. So basically we are looking for a specification for that. And finally developing infrastructure for the modeling as well as algorithmic for automatic analysis. So basically you create a system architecture for the whole system along with the AI component, and it will tell you like if it's wrong, if there is something you need to address within the AI itself. And finally evaluating that trust modeling in the system, like calculating trust values of the communication and of the AI system itself. So what we are expecting here also, one review and one methodology for evaluating trust, because this is one of the biggest issue currently. And yeah, this is all from my side.
Thank you, Abubakar, for presenting this last three challenges regarding the pillars of the ENFIELD project. Now moving to the challenge proposed for the verticals. We will start with the presentation of the challenge for vertical healthcare with Constantina presenting it.
Hello, I hope you can hear me.
Yes, we can.
Okay, perfect. So our idea on this challenge is because we have noticed that when a patient goes through ICU and then discharged from it, there is a high possibility they return and so have worse prognosis on their disease, and leading to maybe increased mortality, longer hospital stays, and maybe financial problems for him and for the hospital. So the challenges we want to focus on is to test and train, as you can see, an AI algorithm that will successfully predict the probability of the ICU readmission of one patient and maybe see what the mortality rate of it afterwards may be. And in order to do that, we'll have to analyze and manage various data sources like biometric data, doctor's notes, patient history, and so on, which, as you may imagine, may be quantitative data or qualitative or text. So there's various types of data there. Also, maybe evaluate and compare the performance of those algorithms since based on what data will be used, there might be a different success of the algorithm. So what is the identified activities for the research is, of course, a literature review, what has been done until now on this aspect, what algorithm has been used for predicting the ICU readmissions, while also testing and implementing a full solution on the problem. This can be done using publicly available data. There is a dataset, the MIMIC, which can be used and has a lot of different kinds of data in it. And finally, the expected results, as you can see here, is one at least peer-reviewed publication. Also, we can create a system of AI algorithm providing these probabilistic predictions on the ICU readmissions. Thank you.
Thank you, Constantino, for your presentation. Presenting the vertical energy challenge, we will have Francisco again.
Thank you. So this challenge is called Systemic and Local Explainer of the System Dynamic Behavior, meaning system here within energy, we're talking about the power system. And the idea is to be able to explain physical behaviors that happen in the system, in the power system, which have local nature, many of them, that today are very hard to understand since a lot of new types of converters with different types of controls are entering the system. And then very complex interactions can happen, which are hard to understand for the human itself. So the idea is to grow a concise set of easily understandable rules that can explain these complex interactions, okay? Utilizing a high fidelity system model, in this case, power system model. So one very important part of this scientific challenge is not only the development of the AI methodology, but also the selection of which power system variables can explain this local phenomenon, since these variables must be able to explain these interactions, let's call it. So what we hope from the scientific challenge in terms of research activities are the development of a methodology capable of creating these small set of interpretable rules by leveraging real data or system events or an high fidelity system model that must be modeled. So this is also part of the research activities, the development of a high fidelity power system model that can be used as an environment for this case. So this environment must have those physical phenomena, those real physical phenomena that have a local nature, let's call it. In terms of expected results, so the method itself that is capable of explaining these human dynamics to human dynamics of the power system, it's one of the expected results. And once again, one peer-reviewed publication, and the code should be open source at the end of this task. The host institution is once again ENFIELD in Porto. Thank you.
Thank you, Francisco, for your presentation. Next, we will have a vertical manufacturing challenge 1 presenter, which will be Amir Sayan.
Can you hear me?
Yes, we can.
Okay, perfect. Well, my name is Shayan from Polimi, and I'm going to present our challenge for vertical manufacturing, which is context-agnostic human detection in robotic cell. In this challenge, we are going to focus on collaborative robots, cobots, and as they become an important part of Industry 5.0, they are going to work in a close approximately with human. So it is important to have a detection system to understand the collaboration between human and robots. And one problem that exists in the industry is that industry has a different type of setups and environments. And if we are going to work on a visual system that try to understand and detect this collaboration, it is important to understand that these changes in the visual representations can affect our model and our system, and it can drop the performance. So as a result, we are going to focus in this challenge to provide a novel idea that can try to mitigate the effect of domain shift problem, which is about that training on a specific data in a specific environment. But when you are trying to test it on different environments, you are be able to have an agnostic representation of your information and your visual feature and more focus on the task and being more focused on the task. So to do that, we want from the candidate to provide us not necessarily, but hopefully a safety system that can try to detect dangerous situations in the environment between human and robot. And this approach and this detection system and his approach should be also provide with a novel idea to mitigate the effect by generalization of your model. So you provide us with a context agnostic detection system. At the end, what is expected to also provide the results that can end up with at least one peer-reviewed journal and publication, hopefully in the top-tier journal. Thank you so much.
Thank you, Amir Shayan. Next, we will have Sophia presenting the challenge number 2 for vertical manufacturing.
Hello, everyone. Can you hear me?
Yes, we can. Go ahead, Sophia.
Okay, I'm Sofia Teocchi from Politecnico di Milano, and today I'm presenting a challenge that focuses on integrating self-X technologies into existing manufacturing systems. So basically, these technologies are designed to be self-configuring, self-healing, self-optimizing, and self-protecting, which means that they can adapt and enhance their functionality with minimal human intervention. So the challenge involves 2 key phases. The first one, in the first one, you will need to conduct research on the state of the art about the self-X capabilities into the manufacturing domain. And this research will provide the knowledge necessary to understand the current advancements. Once you have a solid background, the next phase is to apply this knowledge to a real-world lab-scale environment. Specifically, we have 2 fields of applications. The first one with the automated guided vehicles, and the second one by using biometric sensor for industrial purposes. So these activities will involve working with a data set that is available from these systems and which will be crucial for implementing and testing all these self-X capabilities. Moreover, the architecture for the AI pipelines necessary for the integration of these self-X capabilities is already in place. And your task will be to adapt and optimize in order to incorporate the self-X features into our lab environment. The activities will be carried out in Politecnico di Milano, and we expect at least 1 peer-reviewed journal publication. Thank you.
Thank you, Sophia, for your presentation. And with this one, we finished the presentation of all the 21 challenges proposed for this second ENFIELD Exchange Scheme open call. And now I will present you everything related to the application itself. So my name is Mariana. I'm from Innova Plus, and we are the managers of the open calls that we will have in the ENFIELD project. And today I will present you how you can apply the eligibility criteria and how it goes the evaluation process. So as mentioned in the beginning, as a general information for you regarding these open calls, we aim to engage at least 76 researchers throughout the 3 years of the project through this exchange scheme open calls. This is the second one that we are launching. It will be open until the 14th of October, 5 p.m. CET. So you can apply until then. We expect to grant up to 21 researchers, either in individual or group applications, and the duration of activities needs to span between 3 to 6 months projects. Also, you will receive a mobility allowance of 2,400 euros per month. And the time frame of our activities need to between the 3 and 6 months need to finish in 1 year. So you have 1 year to decide with the host institution when will be this period of mobility. So regarding the eligibility criteria, which is the first important part, PhD candidates, postdocs, and senior researchers all can apply as long as they are from EU member states or Horizon Europe associated countries. You can check which ones are the associated countries in the call for proposals document. You have the link there for the template from Horizon Europe, where you can check all the associated countries that are eligible to do applications in this type of proposals. Also, the PhD candidates need to show their enrollment in the doctoral program, and all of you and postdocs and senior researchers need to show that they are employed at an academic or research organization. Importantly, no candidate can be applied if they are connected to the ENFIELD consortium, to any of the partners of the ENFIELD consortium. The applications can be both individual or in group. The only thing is that if it's a group application, we receive applications either from groups of 2 or 3 researchers, and we need to have the minimum 1 senior researcher or postdoc and 1 PhD candidate. So it can be 1 senior, 1 PhD candidate, or 1 postdoc and 2 PhD candidates, as long as we have at least 1 in each of the categories. So regarding on how to apply, you can go through this link that directly goes to the EU survey that we are using to collect all of our applications. Applications will be received only through this web page survey. Other than that, we will not accept any application via email or any other way. You can also scan right away the code and it will go directly to this website. So first of all, you need to answer all the mandatory questions, accept terms and conditions that we propose, and it will be asked for you to submit the technical annex and the link to your presentation video that we will explain in detail in the next slides how to fill in this document. And again, you have until 14th of October, 5 p.m. CET to submit your proposal in this through this link. So here you can see like a preview of the survey that will be asked to fill. First of all, you need to choose if it's an individual application or a group application, and you need to first select the personal details, name, gender, date of birth, and the position that you have, both if you are an individual application or if it's a group application. In terms of group applications, we'll have first the group leader details, which will be the main contact point for this application to the ENFIELD open call. When regarding the project details, you will be asked to select, and it's mandatory to select one of the challenges that is in the list that you can check everything in the challenge catalog, and also it's the ones that we were presenting here in the slides. each one of the challenges. You need to select which challenge you are applying to. And after that, when the challenge has more than one possible host institution, you need to select, for example, this Green AI one. We have Telenor and Sintef, so you need to drag and drop to for you to have a ranking of your preference. Although this preference will be taken into account, the final decision will be done while we are having the consensus meeting in terms of which is the host institution for the selected candidate. Also, you need to write in the proposal the title that of your project that you are submitting, and indicate right away what is the duration of the project or this exchange project that you are submitting, between 3 and 6 months. You can download directly in the survey the technical annex. I will show you in the next slide what are the things that you need to fill, but you can download directly there, and then it's mandatory to upload it to continue with the submission. And finally, you will be asked to give us the link to your presentation video. Here, we will not asking you to upload directly the video, and it's not possible to upload it directly in the survey of the application. You will be asked to send us the link for us to access it. Make sure that this link is open for us to be, us and the evaluators to be able to see it. If we don't have permission to see the video, it will be considered that you didn't submit the video, and then you will not pass in the first criteria, which is having all of these documents. So please make sure that the video is online for everyone to watch it. So regarding the technical annex, you will be asked first to identify again the challenge that you are applying to, and to state the proposal title. Then you will have an abstract, which needs to have the main objectives of your project, activities, expected results, and added value to the European AI community. And you will have 4 main areas to fill in then in terms of which will be the ones evaluated. So first of all, you will be evaluated regarding the novelty of our proposal and advanced state of the art that it gives to. So you need to explain how your proposal goes beyond state of the art, how you will achieve something that is an innovation new. Then you will need to explain basically the scientific approach that you will use. So mainly the methods and methodologies that you will be using to achieve what you want in the time frame of the project. Then you will need to show us what you envision in terms of dissemination and communication, and having in consideration as well what is expecting from you to deliver in each one of the challenge. So please make sure here that you will explain what you envision in terms of, for example, presentations, publications, events, and even beyond of the project life time frame, what you envision in terms of dissemination and communication activities of your project. And then either the research or the group of researchers need to show their competencies and skills to be able to achieve what they want to achieve during the project. So basically, is the expertise in the field for these researchers. Regarding the video, so the researcher or the group of researchers need to present themselves, and basically what we aim here to understand is the motivation behind the application to the exchange scheme. So we are expecting to have just a simple video of you of a max 2 minutes in English, that you explain what motivates you to apply for this exchange scheme, and why you want to do it. So basically your motivation, again, we need the link to the video, not the video itself. You will not be able to upload the video, but instead we'll ask you the link to access it online. So after you do all of the application process until the 14th of October, Innova will proceed with the eligibility check first of your proposal, if everything is accordingly to what we expect. So your proposal needs to have all of the eligibility criteria that were stated before. We'll check all of that. If you don't pass in this phase, you will receive directly a rejection letter. If you pass through the eligibility check, your proposal will have a remote evaluation from 3 independent researchers from the ENFIELD consortium. After that, they will have internally a consensus meeting for the researcher that evaluated their proposal to discuss it. And then we will decide the ranking and the selected applicants. Here, again, you will also be receiving either a selected notification or a rejection, and you will receive as well the comments to your proposal. In the selected applicants, then we'll proceed with the sub-grant agreement signature, and you will receive the payment right away in the beginning of the project. You will receive the payment of 2,400 euros monthly. That will start with the start of the project until the end of the project, when you deliver what is expected and what was agreed in the sub-grant agreement. So in terms of how the evaluation is done, so as I was saying, the evaluation will be done remotely by 3 senior researchers that belong to organizations from the ENFIELD consortium. They evaluate the technical annex based on the 4 main areas that you needed to describe in the technical annex. So you will be evaluated based on advanced state-of-the-art scientific approach, dissemination and communication, and the capacities of the researcher or the group of researchers to achieve what they propose. Each one of the evaluators will score each one of these topics from 0, which means fails, until 5, which means excellent. And we will have the final score of the application based on the average of the evaluation of the 3 evaluators. If you don't pass the threshold of 3 in each one of the criteria, or 12 in the overall score, the application is automatically rejected. And then we have, in case of ties, the ranking rules will be, the first rule will be the overall score. Then if there is a tie, the highest score in advanced state-of-the-art is the one that is selected. If we still have a tie, we have priority to the highest score in the capacity of the researcher or the group of researchers. Even in the case that we have a tie there, the priority will be given to the applications that have a higher social and environmental impact. And the last rule for ties would be the priority led by women or with a gender balanced team. So based on this criteria, you will have this final score, and we will have the consensus meeting, which will be basically this discussion of the individual evaluations and the decision of the ranking and the selected applicants. When you receive the letter, by the end, you will have the consensus evaluation report, as I stated previously. So this will contain the opinions and the overall score from the evaluators that did the evaluation of your proposal. In case that the decision on selecting or not the applications it's not done in consensus, it will be by a majority of vote of 3 in the group of 3 evaluating. So overall, this is the main process and how it will goes in terms of evaluation. So now if you have questions, please make sure to use the Q&A table in the chat to make your questions. I see that there are some questions here and some of them were already replied to. But we have here a question for a trustworthy AI challenge 4 and 5. So Simak is saying, I am a third-year PhD student working on bias and fairness with a focus on developing fair ML. I'm thinking there can be a link to robustness from fairness perspective. If we look at perturbations or attacks that we want to make our model robust to as changes in the distribution of data, then it gets similar to group fairness problems. Can we really look at it like that? If so, one can leverage the methods of fairness for robustness as well as also bridge the two literatures by finding common language and literature, so on. So the trustworthy AI 4 and 5 presenters, if you want to give us any feedback.
Can you repeat the question?
Yes, so the questions are in the Q&A tab. You can, if you click next to the chat, you can see directly the question. It says trustworthy AI 4 and 5.
To be honest with you, I'm not that expert in this field because it's under NTNU. But what I can suggest is actually, because as you saw, our scope is widely open and we are welcoming any new ideas that can contribute to trustworthiness in AI in general. So what I propose, since you are already working in this field, what I can propose is kind of summarize what a proposal or so on, and you can send it to us as an application. Of course, we're gonna have a look at it. You are muted, Mariana.
Thank you, Vakar. So we have another question also for you for the Trustworthy AI Challenge, the number 5. Specifically, so you can check here the question from Latifa. Specifically, I would like to know if the proposal is expected to present a solution or if it's acceptable to outline a research plan aimed at exploring and developing a solution throughout the grant period.
Yeah, of course, I guess. Because we don't expect to have the solution from the beginning, I guess.
So
right.
Yeah, so it's expected that the researcher can present a research plan with the goal of developing this solution throughout the grant period in collaboration with the host institution. Okay,
yeah,
thank you. So I think most of the questions that we have that some of the applicants are doing are being replied to in the chat. We have here another question for trustworthy AI from Lucas that was already replied to. So it's already solved, this one. So we have another question from Adriana asking what is the minimum time that needs to be spent at the host institution given the fact that we may already have engagements in our base institutions. And what is the expected time to begin the work? So first of all, in terms of the minimum need to spend in the host institution, this is something that is discussed between the host institution and the applicant. It's necessary that throughout the period of this exchange program, you work collaboratively with your host institution and your supervisor, let's say, for this proposal. And it's expected that you spend at least once you go at least once to the host institution and spend a period there. But some of the work can be done remotely as long as you both agree on how you will plan to do that. And in terms of the expected time to begin to work, again, it's something that is discussed between the selected researcher and the host institution. What we need is that you can start from from January, from January 2025 until the end of October 2025, you have these 10 months to have your period of mobility there that needs to be between 3 and 6 years. The exact dates, it's something decided between the candidates and the host institution. And also this period of exchange, if need, it do not need to be done continuously. So if it's something that it makes sense for both the researcher and the host institution in order also to have in consideration other engagements in the institution that they are coming from. You can also split and, for example, do 1 month plus 2 months or 2 months plus 5 plus 4, sorry. So it's something that all of these, we have some flexibility as long as the is a plan that makes sense and that the host institution approves in order to achieve the overall outcome that is expected throughout the exchange scheme. So I don't know if anyone has any other question, because I see that the questions that were written here in the Q&A were meanwhile replied to. So my colleague was telling me that we have another questions. Adriana was before that. Adriana was asking in terms of publication, or there is a deadline for an acceptance notice. I assume that you are saying in terms of the publication acceptance by the journal or the conference or whatever. So in terms of these publications, they need to be submitted in order to be accepted. So submitted or ready for publication. We know that publication, in order to be accepted itself, it takes time. But what we expect, for example, when it's stated in one challenge that we expect a journal publication, it's so it's something that it needs to be ready for submission at the time, let's say, that you end the period of exchange. But the goal here is also to have this collaborative works with different researchers from Europe. So the goal is that after this period, you also keep in touch with the host institution, hopefully, and meanwhile we have the publication. So we have one more question. Let me see here. So we have Madam asking, do the applicants who are not EU citizens need any work permit for the host institution? So we have this visa. So if you are applicants that are not EU citizens, you will need to take care of this visa situation with a host institution. We know that visa, you can come for 90 days, if I'm not mistaken, in a row, but it's something that you need to have a work permit if you are staying half a year, for example. But this is something that already happened in the first exchange scheme. So it's something that then will take care during the subgrant agreement stage that needs to be taken care of depending on the institution that you are going to. Philip is asking if the money for the mobility can be used for research experiments. No, the goal here is that when you apply for these grants, for this exchange scheme, you are already employed at an institution. And the goal of this money that you will receive monthly is to help you in the mobility to the host institution in the project. It's not for you to use for the research itself. Okay. Let's wait if we have one more minute. If there is any other question, please go ahead and add it here in the Q&A section. So I don't see any other questions in this tab now. So thank you all for being here in our webinar. I hope that this was a webinar that was helpful for you to clarify any doubt that you might have regarding the challenge, the technicalities of the challenge, and also the how you need to do to apply. If you have any further doubts, please use the email that we have here to ask any questions. We will be happy to help you. And also go through our website that we have all the information there, and the webinar that was recorded will be also available for you to check if needed. So thank you all for coming today, and I wish you all a great day ahead. Bye-bye.